Hey guys, so in the last lecture we have seen three rotor system, and before that we also seen two rotor and single rotor system, and we also seen equivalent shaft diameter system, in which if the shaft is of different diameters in a two rotor system, then how we can convert into a single equivalent diameter shaft. So that also we have seen. So today we are going to study torsional vibration of a geared system. So torsional vibration of geared system. Torsional vibrations is the name of the chapter of geared system. So this is torsional vibration of geared system. So let's start. So let me draw the diagram. So there will be similarly two rotors, but this time the axis of the rotor are different. That is in parallel direction. So the axis of the rotor are different. So and in between them there will be a pinion and gear system. So between them there will be pinion and gear system. So this is rotor A, this is rotor B, and suppose this rotor is having diameter d1 and this rotor is having moment of inertia Ia. This rotor B is having moment of inertia Ib and having diameter d2. And this is there are two gears. So first is pinion and the other is gear. This is pinion and gear. So now how it will operate. So as you can see that if so in this case so if this rotor is moving in clockwise direction, so the pinion will move in clockwise and the gear will move in anti-clockwise, so the rotor will move in anti-clockwise. So here the power is transmitted through a distance, and the direction of the power is also being reversed. So the direction of the rotation has been reversed and power has been transmitted easily through a distance, some distance that is the length between the pinion and gear. So now what is our goal? So our goal is to convert this system into suppose this equivalent system. So this equivalent system having diameter d, and suppose I am saying that if this is the length L1 and this is length L2. So length L1 is the distance between rotor A and pinion, and length L2 is the distance between rotor B and gear. So now if I want to convert this system into an equivalent system having diameter d, so here d1 and d2 instead of that d, and the total length that is equal to LEQ. So that is equivalent length. So what will be this length and what will be the diameter? Now whenever there are two rotor system, so we know that there will be a node when there is a vibration in the system. So when there is a phase difference, so there will be node in the system. So the diagram for the node will be such that so this is A, this is B, this is LA, this is LB, and this is node, suppose Y. So to obtain an equivalent torsional system, we have to make some following assumption. So to obtain this system, the following assumptions need to be made. So first assumption is the inertia of the shafts and gear are negligible. That is, moment of inertia of the shaft, moment of inertia of the shaft and is equal to 0. The moment of inertia of the gears, that is pinion, is equal to 0, and moment of inertia of gear is equal to 0. They are negligible. Okay, so this is negligible, so there is no backlash. This is the first condition. Then second is the next is, so inertia of the shaft, pinion and gear should be 0. Then the second is that there is no backlash in gear pair. So gear pair, no backlash, no backlash. Then the third point is the gear teeth are rigid and are not subjected to distortion under the tooth loads. So the teeth are rigid and are not subjected to distortion under the tooth loads. So not subjected to distortion. So not subjected to distortion under tooth loads. So under tooth loads. So these are the various assumptions that we made to convert this system to equivalent system. Now, to convert this system into equivalent system, we will use the relays method, that is kinetic energy, and that is energy of both the system will be equal, should be equal. So we will use first kinetic energy. So that is kinetic energy of actual will be equal to kinetic energy of equivalent. So kinetic energy of actual should be equal to kinetic energy of equivalent. So 1 by 2. However, now what is the kinetic energy of actual? So what is the formula first? So formula is 1 by 2. As we know that in linear we use mv square. So in rotational we use I omega square. Okay, so here also 1 by 2 I omega square. But what will be the I? So actual, in actual we are taking so what kinetic energy will we have to consider? So first this is the actual system. So here kinetic energy, so I, so there are two rotors, so both kinetic energy we need to add. So first is IA and omega p square. So the speed, omega is speed, so that is in rotational speed, so angular velocity. So this and this speed will be the same, so that we are saying is omega p, so as pinion speed, and IA we are using, and here for rotor B, IB and omega g square. So here I am saying that actual will be IA omega p square plus 1 by 2 IB omega g square. So this is the actual, so this is the actual, so this total is the actual, and now the equivalent. So in equivalent, the IA and IB will not change. The moment of inertia, the rotors are not changing. So what we are changing, only the shaft we are changing. So IA we are not changing here. So IA will be the same, and P, it will be the speed of the rotor A will be same as the rotor B. Okay, so that will be IP. So now the second rotor. So now as in this equivalent system, as this is an equivalent system, they are on the same shaft. So the speed of both the rotor will be the same. Here it will not be the case. Here it will not be the case because here the speed transfer will depend on the teeth of the pinion and gear, number of teeths and the diameter of the pinion and gear. So but here they are on the same shaft though, so here the speed will be both of rotor A and rotor B will be the same. So here 1 by 2, suppose I am writing I omega square, so here the speed will be omega p square. Now here the moment of inertia of rotor B, So here what will be changing? So rotor A we are not changing. So here the moment of inertia rotor B will be changed. So moment of inertia of rotor B we are changing. So we are denoting it as omega B dash. So now if I open the brackets, so this first term will get cancelled. So we are left with second term. So in second term 1 by 2 will get cancelled. So IB omega G square will be equal to IB dash omega P square. So if I make the subject of IB dash, what is the IB dash? That is the moment of inertia of new rotor. So IB dash will be equal to IB into omega G divided by omega P whole square. So now this is the uh, angular velocities ratio, and this we can write it as gear ratio, so that we can call it IB into GR square. IB into GR square. So this is the kinetic energy actual and kinetic energy equivalent. Now if I want to change, now this is the first condition. So now we also have to verify the second condition. So what is the second condition? So the second condition is the potential energy. So energy actual should be equal to the potential energy equivalent. So what is the formula for potential energy? So for linear systems in vibration, we know the formula is 1 half kx. So for linear we use uh, 1 half f into x, or we use 1 by half kx square. Generally we use 1 half kx square, or 1 by 2 fx, because f is kx, as we know that f is equal to kx. So in rotor system we will use the formula, that is any formula we can use. So but instead of force, here it will be torque, so that is 1 by t, and instead of uh, linear distance, we will use the angular distance, that is angle, that is theta. There will be 1 by 2 t theta, or we can use 1 by 2 k torsional into theta square. And here instead of f, uh, so t is equal to kt into theta. We have to use this formulas. So now for second potential energy actual is equal to potential energy equivalent. So we will use this formula. So that is 1 by 2 t theta is equal to 1 by 2 t theta. Now here potential energy we are calculating. So we will calculate the potential energy uh, of actual system. So for actual system, so if we consider similarly for the first rotor, the potential energy will be the same. So because there is no change in the I, and there is no change in the omega p, so it will be the same. So we are only considering the second rotor system comparing. So here the if I take, so here we are taking g, that is 1 by 2 tg theta g, and here the speed is being taken, the speed of this equivalent system is taken as the speed of the pinion. So we will use here p for the equivalent system and g for the rotor system, actual system. So we'll take tg theta g, tp theta p. So 1 by 2 1 by 2 cancel. Now now as we know that t theta by j is equal to g by l. So g by l, so this is the formula. So if I want to find the value of t, so I will get that, sorry, here as we know that formula is t by j, sorry, so the formula is t by j is equal to g theta by l. So this is the formula if I want to find t. So I will get t is equal to g j by theta l. So here we will use this formula. So instead of t we will get g j theta square by l is equal to g j theta square by l. Now theta is here G and theta is here P. Now as G is models of rigidity, so it will be the same as we are considering. So G will be same, so it will get cancelled out. J is the shaft diameter, so the diameter will be different here. So original system diameter will be different and the final system diameter is different. So the original system diameter is, suppose I am denoting by G and here P, and the length, so the length will also be different. So the length, if I am taking for original system here for rotor B, here L2, then here we don't know what is the length, so I am taking as similarly L2 dash, so just as L2 dash, so here L2 and here L2 dash. So I am left with I theta g, sorry, j g theta g. Now j is polar moment of inertia and its formula is pi by 32 d raised to 4. So I will just put this formula, so pi by 32 will get cancelled, so I will put, I'm putting just d by 4, so instead of j, so it will be d2 raised to 4 theta g square upon L2 square. So as we know that we are taking for the second system only, and here for the equivalent system we will use D1. So D1, so first diameter raised to 4 into theta p square upon L2 dash. So this is the formula. Now let me take similar terms on the one side. So let me take L2 dash on the left. So L2 dash upon uh, L, sorry, here there is no square, so here is just L2, so L2 dash upon L2 is equal to D1 raised to 4 divided by D2 raised to 4 into theta p by theta g whole square, theta p by theta g whole square. Now if I find the L2 dash, so L2 dash will be equal to L2 into d1 by d2 raised to 4 into theta p by theta g whole square. Now what is theta p by theta g? So as we have defined that omega g by omega p, here we have defined as gear ratio. So similarly the ratio of the theta p by theta g will also be a gear ratio, so that will be gr square, that will be gr square. So here the total length L will be equal to L1 plus L2 dash. So L2 dash is L1 plus L2 into d1 by d2 is to 4 into gr square. So this is the equivalent length of the equivalent system and having a diameter that is d1, so having equivalent diameter d1. So this is the formula for obtaining the equivalent system. So I hope you understood this whole theory. We'll see few examples which we will, due to which it will get more and more clearer what is this theory is saying. So hope to see you in the next lecture, and I'll just revise what we have studied today. So we have seen the torsional vibration gear system where two rotors are is the power is transmitting between two rotors with the pinion and gear having diameter d1 d2, moment of inertia ia ib, having length l1 and l2. So so the direction is being reversed here, and if you have to convert it into single two rotor system having on the same diameter, then we have to find the equivalent length and equivalent diameter. So diameter we're considering as d1 as equivalent, and so we have to find the equivalent length. So what will the equivalent length? So L1 we are taking as it is, and L2 we are finding here, and similarly the L2 we are finding with the help of potential energy equivalent, and by comparing the potential energy, and here the moment of inertia of IB we are finding for the new rotor system, no equivalent rotor system, with the help of kinetic energy comparison. So I hope the both the conditions should satisfy, and also assumptions which is required, which are essential to prove this theory right, or which is right. Okay, so I hope you understood this and hope to see you in the next lecture. So thank you very much.